So we're talking about complementary colors here, and I have the complementary pairs laid out. And we're going to start simple, and then we'll get a little bit more theoretical as the video progresses. So, complementary colors are supposed to be the idea that you have pairs of colors that are opposite each other. Now, how are they opposite is a good question to start with. And complementary refers to hue only. Value and intensity can play a role in how they're interacting and everything, but when we talk about complementary colors, we're talking about purple and yellow and orange and blue. So first, there's only 6 of them, so they're kind of easy to remember. And we all know the basic 6 colors already, but the way that they're paired, if you need a mechanism for remembering it, this works where I live in the American South, where we have Auburn University's colors, Louisiana State's colors, and we have Christmas. And so if you live in Cincinnati or something, I don't know, come up with your own. But in the meantime, that's going to work. Now, when complementary colors come together, they're supposed to be opposite. So when they mix together, they are supposed to neutralize each other, and that's why I have them set up in these transparencies, which is something that we'll discuss later. In later videos, the transparency idea. But I thought I would throw that together just to show you that when they overlap, the new color ends up being a little bit duller. None of these are perfect, but the idea is that these are all bright, and then the inside color is duller. And that is going to be true when it comes to mixing. When it comes to how the colors interact with each other, now that's a different story, and that gets a little bit complicated. But let's back up and explain a few things. So I'm going to mess all this up and then come back. So the way that color works in real sort of physical space is that color is a line. What am I missing? Orange. So the spectrum itself is a line. There are colors over here that we can't see. There are colors over here that we can't see. If you're a bird, I forget which side, but birds can see. They have a whole nother section of spectrum off to one side. But if the spectrum is a line, then this is basically how it works. Purple is on one end, red is on the other. For some reason, I forget the actual explanation why, but there are fewer reds in our visual universe than are the other colors. And so when you're using red, it tends to look a little bit flatter. So when you're using red, you want to make sure that you have as many varieties of red at your disposal as possible. But anyway, that's not the point I wanted to get to. What I wanted to get to is that when Isaac Newton came along and sort of figured out the spectrum and how to view it, he also noticed that if you make the spectrum, if you take the purple end and the red end and you link them up, it makes a circle. And so that's what we refer to as the color wheel. Now, light is not a circle, light is a line. But this circle idea has some coincidences in it that are useful. It lines up our complements for us. Now, the complementary color idea, where if you make a circle, the complements are automatically across from each other, that requires that a lot of things just sort of fall into place, and that is not how the spectrum works. Because remember, the spectrum is a line. So we can use the idea that they're opposite each other or across from each other in terms of mixing. We can do that. So if you mix a yellow that's leaning a little bit towards green with a purple that leans a little bit more towards red, you're going to be able to use those colors to neutralize each other. And then the same thing, if you have a green that leans towards blue, you're actually going to want a red that leans a little bit more towards orange. So maybe a red that's a little bit more like that would be better there. But in any case, I have a whole series of videos on complementary color mixing that deals with the specifics of how to think about that. And mostly it has to do with pairing up the hues on both sides and then making sure their values are the same. But anyway, back to the color wheel. Okay, so to wrap up the complementary color thing, the last thing I want to talk about is how the difference between how complements look next to each other and their actual complementary nature. So I'm going to get rid of these, and I'm going to bring in some other combinations that I have going here. So now this part is going to be a little harder to understand, but we're going to have a go at it anyway. So if you look at these are complementary relationships, and I just started with a single color. But one side is the mixing complement, and the other side is the visual complement. Now, the visual complement thing, we could talk about that for quite a while, and I want to keep this explanation as simple as I can. But the mixing complement is where if you have a purple that leans towards blue, the mixing complement to that would be a yellow that leans towards orange. And a green that leans towards yellow, you want a red that leans towards purple. If you have this is kind of a middle blue, so maybe we would want a middle orange here. We could get away with, I chose this one because the values are similar. But if we wanted more of a middle orange, we could, that would work too. Now the other color on the other side is what I refer to as the visual complement. Now remember, when we go back to the idea that the spectrum is a line, the actual hue opposite of any given color has nothing to do with what's across from it in a circle, because that circle doesn't exist. So, and the way that we prove that is if we make an after image of any of our starting colors, if the color wheel idea was right, we would end up with this, but we don't. We end up with this. So if you do an after image of this color, when you pull it away, you're going to end up with a color that looks very similar to this. Not a yellow that leans towards orange, but a yellow that leans towards green, which is very interesting. So now we can go through that for all of them. So if we do an after image for this one, we still get an orange because it's a middle blue, but it's much, much yellower. And then if we go here, these two make a neutral, but if we're mixing them, but when we do the after image, we get a straight up purple out of this green. And another thing to point out is that if we mixed the visual complements, they would not neutralize each other. This would make a really dull green. This would make, it would not make a gray. It would make some sort of a weird, either a purple brown or a green brown. And then these two would probably neutralize each other pretty well, but it doesn't have enough yellow in it or orange in it to actually neutralize it. So I don't know what would happen if we mix these two. Again, you'd get some sort of a gray, brownish yellow, I think. But since they're both kind of cool, we're going to end up with sort of a brown, I would expect. So I bring that up to just get the viewer thinking about how these colors actually work in real space and in a practical sense. So if you are trying to find the right orange to put next to a blue that you want to be complementary in a composition or in a painting or in something, try that. Try making the after image first and then using the after image to find that color and put them together. But if you're trying to find just the right orange to mix with the blue to neutralize it, you're going to have to do the comparison of the different hues. Like we did before, if you have a blue that leans slightly towards purple, you need an orange that leans slightly towards yellow.